So now we're going to start applying our trig our ratios to right angle triangle problems. So first thing you always do when you're given the actual triangle is you find your given angle. This is our given angle. How do I know that? It's got something written there, whether it's got like your angle sign, whether it's got a Greek symbol. This is telling you where your given angle is. Okay, the other way they can do it is they can say angle A. So they're saying this is where you have to go. So for this question, they want us to come up with these two trig ratios. Regardless of whatever trig ratios I have to identify my sides. So across from the 90 is the hypotenuse. This is our given angle. We have to go opposite the given angle to find our opposite side. And then the side that's not opposite or hypotenuse is our adjacent side. We want to do that right off the get-go. These are the things you do before I even start like thinking about what's going on. I'm like, oh, opposite, adjacent, blah, blah, blah. So then we have to look at what ratios they want. They want sine and they want cotangent. I recognize this as a primary trig ratio, but this is a reciprocal trig ratio, so a little bit of thinking for that one. So SOHCAHTOA. As long as you know SOHCAHTOA, you can figure out the reciprocal ones. So sine is opposite divided by hypotenuse. Opposite is 6 divided by hypotenuse. Sine of the angle is 6 divided by 10, 0.6. Nice. Okay, cotangent is the reciprocal of tan. Okay. So we're going to use TOA, but we're going to flip these around because it's reciprocal. So for us, cotangent is actually adjacent over opposite. And then we can adjacent over opposite. Cot of the angle. 8 divided by 6 is a 1.33333333. Okay. Next thing we're going to do is actually evaluate to get some answers. Okay. With these questions, first thing you have to do is look at them and say, are they a primary trig ratio or are they reciprocal? Primary means use a calculator. All we're doing is we're plugging in either sine 25 equals, or if you've got a little bit of an older calculator, you might have to go 25 sine, like telling it, I want the 25th, 25 is the angle, and I want you to calculate the sine of it. So you have to know whatever your calculator is, but regardless, it has to be in degrees. You can't have a R, you can't have a grad. I would be walking around the classroom right now, making you all take out your calculators and show me that you had a degree sign up there. Like, that's what I would be doing right at this moment. So I want you to double check that you're in degrees. So sine 25, close the bracket. We're going to go 4 decimal places. All I did was plug it into my calculator. I got 0.4226, and then it's a 1, so it's going to stay as a 6. Not bad. Plug it into the calculator. Well, okay, now let's get crazy right off the bat. So our second one we're looking at here, we're like, okay, this is a reciprocal, which means that it is the flip of tan. So we have to recognize the reciprocal here is tan. So if I go 1 divided by tan of 15, I'll get the answer of cotangent. And we have to force things back into cos, tan, and sine. Because if you look at your calculator, you don't have a cotangent button. So anytime you want to solve questions that have to do with the reciprocal, you have to force them back into cos, sine, and tan. So this we can solve on a calculator now. 1 divided by tan of 15, 3.3721. No, that was backwards. 73. You can see my little bit of dyslexia coming out there. Okay, there we go. Next. Secant. All right, what was our, this is a reciprocal. It looks like sine, but it's not. What is our reciprocal function for secant? Cosecant. Okay, secant, cosecant. Maybe that helps? No, that's not. Megan, I just screwed up so far into the little thing. It's secant and cosine, not cosecant. My bad. Sorry, kidlets. Okay. Here, so cos is our reciprocal, which means in order to solve this, we have to go 1 divided by cos of it. $28.3. 1.1357. 1357. Okay. 4 decimal places. Tan normal. Just use your calculator. Boom. Tan 72.5. 3.1716. So this one is nice. Okay, we're going to go backwards now.